In this 12.2 quick check, okay, we're looking at the standard reduction potentials. So this kind of information here would be given to us on the as a chart, on a test or a quiz, and we just have to know what to deal with, what to do with it. So we're going to start off up here, and it says rewrite the standard reduction potentials as oxidation potentials. So again, if we're going to change it, we have three things to change. One, we're going to take this guy and we're going to switch it around. So we're going to say zinc metal turns into zinc 2 plus 2 electrons. Okay, we're changing the name to oxidation, and then we change the sign on this, so now it's positive 0.763 volts. Okay, we're going to do the same thing for copper. Okay, we're going to turn that around, so copper metal turns into copper 2 plus 2 electrons. Okay, we change the name to oxidation, and now its voltage is going to be negative 0.337 volts. Now, we don't necessarily have to do these. It's just, the idea that we can turn them back and forth. So we're going to go back here now. It says, okay, write the half reactions for the cathode and the anode when zinc and copper are used to make an electrochemical cell. We're talking about a galvanic cell, a battery. So we say, okay, copper and zinc. We start off and say, well, here's copper, positive 0.337. Here's zinc, negative 0.337. So what that means is the copper is going to happen as is. So this is the reaction we're going to use, and this is the voltage we're going to use. And for the other one, okay, the lower one, the zinc, okay, this is going to be the one we're using. This is going to be oxidation, and this will be the voltage that we use. So that's why we want to be able to turn them back and forth, because we may need to use the reaction as is, or we may need to turn it around. Okay, so we're going down here. So what's our cathode reaction? Cathode always happens at the reduction. Reduction always happens at the cathode. That's why we remember red cat. So reduction at the cathode. And anox. Okay, the anode is where oxidation takes place. Okay, down here. So at the cathode we have copper 2 plus, picking up 2 electrons and becoming copper metal. And the voltage for that is going to be positive 0.337 volts. At the anode, okay, we have the zinc. Now the zinc is going to work backwards to the way it's written in the chart because it's really oxidation. So zinc metal turns into zinc ions and 2 electrons. And the overall reaction, we can see that 2 electrons are going to cancel out. So we're going to have copper 2 plus zinc metal turns into zinc 2 plus copper metal. Oh, and I left this off. Okay, the oxidation potential is positive 0.763 volts. So when we add those together to get the voltage of the cell, the voltage of the cell is 1.00 volts. And that's a positive number. Okay, now draw the cell for this. So it says do the anode on the left and the cathode on the right. So let's just label these so we don't forget. And we do standard things. So when we say we're going to have liquid in both of these, and we're going to have a piece of metal in each of these. So that's the standard thing. And then we're going to put in a salt bridge in between the two of them. Okay, we'll come back to that in a minute. Okay, so what has happened? Okay, we're saying that the cathode is the copper. So the cathode, this is a piece of copper, and that means this is a piece of zinc metal. And this solution then has 1 molar zinc ions, so zinc nitrate, something like that. And this one over here would be 1 molar copper ions, and again, copper nitrate, copper sulfate, something like that. Okay, the electrons are going to flow from the anode to the cathode. And the voltage of this whole cell, we said, is going to be positive 1.10 volts. So if we had a voltmeter hooked up to this, okay, we would see that as 1.10 volts that we had before. Okay, then, so it says draw the anode on the left, cathode to indicate the voltage, direction of electrons, the anode equation and the cathode equation. Okay, so at the copper equation, we just copy it from up here. The copper equation is copper 2 plus, picking up 2 electrons and becoming copper metal. Okay, that is reduction, which is why this is the cathode. And at the other side, just copy this off our chart up here, the zinc metal is turning into zinc 2 plus 2 electrons. Okay, that's oxidation, which occurs at the anode. And what else do we do? The overall equation. Okay, the overall equation is right here. I'm just going to say here it is. That'll be easier for us. And the salt bridge. So the salt bridge here is in the middle. I'm going to draw it red now. And what that allows to happen is the ions to flow. The electrons flow on the outside, the ions flow on the inside, because here we are making more positives, and those positives need to have a place to go, so they're going to go this direction. Over here, we are using up positives, which means because there's a positive and negative ions in our solution, that there's too many negative ions, and those negative ions are going to go back this other way. And one thing to notice about that is the anions go toward the anode, that's the negative ions, and the positive cations go toward the cathode. That helps you figure out. So this salt bridge is a place where the ions can move so that the solutions can stay neutral. So the electrons move along the outside and the electrons move on the inside, and that completes the circuit. That is this quick check.